HEOMD at headquarters, and both the program office, Carlos Torres, and as mentioned before, Jen Gustetic and Joseph Grant. Myself, over 20 years of engineering consulting and military experience. And just a little bit about me. I know that all of the folks here are very passionate about making the process of doing business with NASA, in particularly, is trying to make this more streamlined for you. And just a year ago, I was in your place working for a small business and wanting to figure out how to bring my ideas to life and help NASA innovate. And so, in terms of rules of engagement for this session, we'll try to make or give you opportunities to, at the end of this session, there'll be a mic that'll be passed around so that the folks that are in virtual land will be able to hear your questions as well. And please ensure to just to provide your patience as we go through this particular session. Without further ado, Dr. Keith Woodman is going to be the next presenter. He's the SBIR lead for NASA's Human Exploration Operations Mission Directorate. He's been a part of NASA since 1988. I've had the personal pleasure of working with him on NASA's road tours for HBCUs and MSIs. Please welcome Dr. Woodman.
Good morning. Thank you. So originally, Jitendra Joshi, who is the HEOMD rep to SBIR, was supposed to be giving this talk, but he couldn't make it and asked if I would step in. And before I joined SBIR about 3 years ago, I had worked for HEOMD since it became HEOMD, working for the Constellation program. And so I've worked on a lot of the projects in HEOMD, helped oversee the work at Langley for a lot of them. So I'll do my best to give this talk justice. I think Jitendra's actually listening in. I don't know if he'll be able to chime in at all, but I know he's listening. So with that. All right. So since the early 70s, back when we finished up the Apollo program, NASA has been primarily concentrating on learning to live and work in lower Earth orbit. We did that with the shuttle program, and of course still with the ISS. And we've been very successful at that. We know a lot about what it takes to live and operate in low Earth orbit. We've done so well now that we're actually starting to transition over the access to LEO to the commercial companies. That's because we feel that they can make a business case for this, and you know, NASA doesn't want to be in competition with the business. We want to be helping business. So we're transitioning out. That's why you hear so many companies like SpaceX, Blue Origin, like them starting to develop their own launch systems. What this does for NASA is it frees us up to do what we really want to do, and that's to go out farther and for longer periods of time. I know a lot of people would make the case, well, why don't we just go directly to Mars? I mean, that's you know, been the what people would want to do, and yes, could that is definitely a possibility, but I would say that would take revolutionary jumps in technology to do that right off the bat. What I think most people are thinking is we're going to do it kind of like what we did with LEO. We're going to go out a little bit further. We're going to learn how to operate and work there, and then we'll go out further from that. So as you see at this chart, what we're talking about doing now in the 2020 is going to assist lunar space. And that could mean going back to the moon potentially, or it could mean talking about going to the space around the moon. And you know, some people might say, well, that doesn't seem much further out than LEO, but to tell you the truth, it's actually, it really increases the operational complexity and also the risk of the missions. Low Earth orbit, you don't have to worry so much about gamma radiation. You're still protected by the Earth's magnetic field. Going out to the lunar environment, you don't have that protection. Also against the massive solar rays. In low Earth orbit, you're able to get back to Earth relatively quickly. If you have a system go bad, you can get it replaced fairly quickly. That's not the case once you go out to lunar orbit and beyond. And so that's why we're going to be looking to go out and start testing systems in that environment, test them for the reliability, which you're going to have, and their autonomy, and also to make sure that they can withstand the environment, especially the radiation environment. Okay, so how is NASA leading human exploration? First, and Jim Reuter touched on this quite a bit in his talk, maximizing the ISS. It's a great test bed for technologies, and I'll get into that more as we go along. Actively promoting LEO commercialization, as I said, you can see that with companies like SpaceX, Blue Origin, and we'll talk about some other ones when we talk about launch services. Resolving the human health and performance challenges. When you're talking about going to Mars, and you're talking potentially being away from the Earth for 2 years in an extremely hazard environment. I mean, right off the bat, you're talking about problems, produced by microgravity. As I said before, problems with caused by the more intense radiation environment, and also the psychological aspects are something that have to be addressed. I mean, you've got several astronauts up there in a very small contained vehicle. Once you get past the moon, it's going to be really hard for a rescue. You're really you're on your own, and that's just a high stress environment. This is some of the things we have to learn how to deal with. As you can tell, and a lot of the reason why y'all are here, expanding partnerships with the commercial industry. Our NASA budget, unfortunately, it's stable. It's not being cut like other federal agencies, but it's not exactly, we don't see it going up a lot. And that means that we have to leverage more and more with the commercial partners. And I think that's a good thing. And that's the reason why some of you are here today. Growing international partnerships, that's also another thing that he was looking at. A Mars mission is going to be extremely expensive. And, it's something that, that all mankind, should be a part of. And I think that's why they're reaching out so aggressively to international partners. Yeah, it's part of the sharing the cost, but also it's just that sense of adventure, and just it would be the most monumental thing that's ever been done, since the moon landing. So, they want to build those international partnerships. Building the critical space infrastructure. So, like I said before, and I'll talk a little bit more, you've got to worry about your communication systems. How are you going to communicate to these astronauts who are going out further for longer? How are you going to, get them supplies they need, the logistics? And finally, enabling capabilities to explore multiple destinations. So yeah, Mars is put out there as the ultimate destination, but there's other destinations potentially on the way, the moon, or even near Earth asteroids. Excuse me, I had to take notes because Jitendra was just filling me up with notes the other day. All right, so HEOMD and SBIR have a nice, long relationship and very successful relationship. Like it says here, solicit and select the best technical efforts that can align with NASA interests, that can be accomplished by small businesses with SBIR resource, and that have a high potential for commercialization. When we think commercialization, we think potentially inside NASA being infused into our missions, or outside of NASA, producing a product that the commercial industry likes and wants to buy. That's really a big success. And so what we're entering into now is our solicitation development. The first thing that we do there is establish our overall topics for HEOMD, the guiding principles. Those are basically defined by our large strategic knowledge gaps. Where do we need the most development at? Our next step will be to go through and determine our subtopics. So we'll go out to NASA and say, here are the topics that we're going to go forward with in the solicitation this year from HEOMD, and we want you to start proposing subtopics. And what's really nice about this year is we've been able to get some input from y'all, from the commercial sector, as we go into that, getting that feedback with the RFI that was released early and with this industry day. So it's really important that, when we develop the task that we're going to be asking, it's for small business. We don't we don't consider, SBIR, we don't put them on the critical path for our flight projects. Basically, when a HEO manager thinks about SBIR, a project manager, what they'll think is, okay, I've got my baseline technology, but man, if I could just go out and, there's this other technology that, if we could get that, invested in and maybe see if it's a potential, that's something that could reduce my cost risk, my schedule risk, my technical risk. And that's where SBIR comes in. And it actually proves to be very successful, as I'll go into in many examples. So we look at SBIR as a mitigation path for us. And ultimately, like I said, SBIR there is to help small businesses. That's really our main goal, is to help American small businesses. And, encourage, for us, a sustainable supply chain, because, we don't want, sometimes, yeah, we have to have companies make a one-up kind of thing, but, what we want is technology is going to be there over time, because we're talking about systems that are going to be flying for, potentially decades, and you want to have a supply chain to refurbish those and to be able to maintain those over those decades. And ultimately, like I said before, when it comes to commercialization, one of the big things, either outside of NASA or I will talk about with several examples, integrating technologies into our current HEO missions. All right, so I'm sorry, these slides are a little bit different than the ones I have. The slide I have here is for the overall HEO, but basically space communication and navigation is one of the major aspects or major missions under HEO. And as you can imagine, good communications and navigation are critical to get astronauts to Mars safe. And as Jim also talked about, a lot of activity going on, especially that first row up there with the advanced technologies. And as you see there, the final goal over there around the 2025 is to have low-cost optical and RF ground terminals. We're really starting to push the optical communication. It does so much for us. We need the higher data rates. The astronauts want to be able to stay in better communication, a more reliable communication, and they also want to be able to transmit back as much data as possible. Also, whenever you're sending something in space, whether it's a comm unit or whatever, you want lower mass and lower power, and optical really does that for you. And also, you want to increase the reliability of your communication systems, because they've got to be ultra reliable if you're talking about a 2-year mission to Mars. All right, now we get into some of the examples of just SBIR successes, and this one has to do with deep space communication. Actually, there's two here. So the first one is by a company called Control Dynamics Incorporated, and basically they developed vibration isolation for laser comm systems. It's very important that you can keep your communication platform as vibration proof as possible. And they've, through an SBIR funding, developed a technology to do that. And FiberTech out of Virginia developed a laser transmitter assembly for transmitting the downlinks. And it really increased the peak to average power ratio and just made a lot of improvements. And it's something that AES is, or excuse me, the SCAN has really invested in and wants to get to the next level. So, like I said, we'll be talking about a lot of SBIR successes. And they love to, the thing about HEO is they love to fly SBIR technology. All right, so another major organization under HEO is the Launch Services Program. And their goal is to maximize launch mission success and ensure the long-term launch services. And as you can see in the bottom right box there, is promote the evolution of the U.S. space launch market. And what's exciting about that, seeing all those emerging launch vehicles there, is what that means is competition, which leads to lower launch costs. And lower launch costs means you can put more and more stuff into space. And that's really, really what we want to get to with the Launch Services Program. All right, so as you heard earlier today, the ISS is a very very busy place. And we've got we got cases running the national lab with ISS and NASA running these things that are very NASA specific. Some things overlap like earth science and biotechnology. But you can see it's just a wide range of disciplines at work on the ISS. And so what makes ISS, such a neat place? Well, you can't cancel out gravity on the Earth. No matter how hard you try, gravity's always pulling on you on the Earth. But on the ISS, you're not getting that gravity pull. And so it provides you a very unique place to experiment with, having a no gravity environment. All right. So, like I said, this chart shows you just about everything is being tested up on the ISS. If it can be shown as being something that needs to be tested in space. You go up there to material structures and manufacturing. You've got Bigelow, and also talk about 3D assembly or manufacturing. It's also being done on ISS. Down there with the robotics, you have Robonaut. You also have the various arms that are there for construction at ISS. Like I said, radiation, that was something I oversaw at Langley for many years. A lot of study being done in reducing radiation exposure for astronauts. ISS, you do a lot with the solar, trying different halves, different materials and stuff. And that's something we'll have to develop even more as we go out further. But it's such a good test bed right there. So like Jim Reuter talked about, we have a lot of good internal and external payloads on the ISS. There's just a lot of opportunity for testing up there. And I believe he also talked about this. This was started out as a phase 1 SBIR. I tell you, if you think about being an astronaut, you think about going to Mars in 2 years, just think how important it would be to have fresh food. It just, it's not only good for the body, but it's also going to be good for your mental health as well. Eating stuff that's not goo, basically, which I think is what they have to kind of eat now. So basically, back in 1995, at level 2, phase 2 award was given to produce the veggie system. It's just it's not only about producing fresh food, but also think of the other advantages that having something like this on board the ISS or any other spacecraft gives you. It's not only just fresh food; it's also fresh air, that you can breathe. And you can see the evolution here from just a basic little flight experiment over to the 2015 green wall. And really that shows a very systems approach to what you're doing, because okay, so now not only are you providing fresh food and air purification, but also if you're making your walls out of this kind of this biomass technology, you're also increasing your radiation protection, because basically the bio stuff has a high hydrogen content, and it's helping you reduce your radiation exposure. So it's a very system level approach and solution to several problems, and that's what makes it so important. All right, advanced exploration systems. So that's Jitendra is the chief technologist for that, and for 5 years before I joined SBIR, I was part of AES, overseeing all their work at Langley, and also was the deputy for their avionics project. So when we look at the different parts of AES, HAB systems is one I'm very familiar with. That Bigelow expandable falls under habitation systems. Docking habitat design, docking hatchet design falls under that. All the life support, Dan Barter, I think actually Dan's talking during this conference. It's just incredible amount of work there, and also logistics reduction. And a lot of people don't think about logistics reduction, but as you're going deeper into space, logistics becomes a bigger and bigger problem. What to bring, what not to bring, what can you build potentially with 3D manufacturing. Logistics really becomes a a major factor as you start going out further and further. From there, we have vehicle systems, that's propulsion and lander technology. The foundational systems, that's where I was with the avionics and a lot of ground operations technology, and also that's where the in-space manufacturing falls. And I'm going to skip robotic precursors right now because we have a whole chart on that, because that's just full of opportunity in SBIR design. Okay, and so Jim also mentioned this in his talk, the full-size ground prototype development. So we have 5 industry partners developing different kinds of prototypes, different approaches to ways we can utilize systems that are going up, or build new systems as we approach, trying to head out to cislunar space. Okay. So I really, really like this chart. The small companies out there should really like this chart too, because this is a great gap chart for what we need in habitations. So first right up there, and I believe Dan Barr will be talking about this more, is life support. So there under today at ISS, you can see, okay, we can recover about 42% of our oxygen, but as we're heading out to Mars, that's got to be 75% or above. We can right now recover 9% of our water, which is not bad, but when you're going to Mars mission, estimates are you're going to need 98% water covering. So environmental monitoring, so much stuff now, we have to take samples and send them back down to the ground for analysis. If you're going out to deep space, you can't do that anymore. You want to do monitoring in space, real time, when it's happening there. On crew health, right now, if you see exercise equipment that's for the ISS, it's big, it's bulky, it's heavy. We can only launch so much towards Mars, and this is the stuff that has to go with the astronauts. So it's got to be smaller, it's got to be more efficient. Also, medicine on board. That's another problem. What are you going to have to take? How are you going to do that? Is there potentially technology out there you can make your own medicines en route? You have to look at these possibilities. And then, of course, the food resupply, that's kind of like where that veggie system, that green wall comes in. And finally, EVA, extra vehicle activity. Really, one of the big pushes there is about increasing mobility for the astronauts, because right now it's really hard to move and everything. And you've probably, in the news, have seen different news articles on new astronaut suit designs and stuff like that to allow them more mobility and greater protection. All right. So infusion in the planetary missions, this is a great one. I think Jen talked about drilling, and this comes under AES, Resource Prospector. Hopefully looking to launch early in the early 2020s, and it will be going up to the lunar poles and looking for volatiles there. Volatiles, water, oxygen, things we can use to make fuel, to make water, to make oxygen. You can imagine that's an extremely challenging design, having to go to the lunar poles, very cold, very desolate region. Don't know, you might be out of the sun, you got to power thing. Just a lot of things there, but just the drill itself is going to have to be very robust to withstand that environment. And so that's, like I said, started out as a SBIR and has gone a long ways. Another one that we should be talking about here is the Mars Oxygen ISRU experiment, also called MOXIE, which is going up on the Mars 2020 rover. And it's going to be attempting to produce oxygen from the Martian environment, which is very much, carbon dioxide. And of course, how, if it proves out they can do that, it's amazing. That really helps your ground operations when you get to Mars, if you can start producing your own oxygen for breathable air and also fuel production. And that small SBIR company called Air Squared made this cold compressor for that technology. So another SBIR infusion success. All right. Another flight example, in 2014, we flew the first in-space 3D printer onto the ISS. And as I was discussed before, logistics is a major problem. You've got a lot of, let's say, give an example, packing material. Okay, when you go up, you've got a lot of stuff that had to be packed in a certain way. Like you take that packing material and melt it and now use it to print other stuff that you need up there. Like I said, logistics is a massive problem as you go out further. You want to be able to use everything you bring. You really don't want much waste. If it's a waste product, can you reuse it? 3D printing, is a potential way of doing that. It really adds a lot of robustness for your missions if you're able to make stuff that you need out of stuff that you don't need anymore. And so, like I said, another SBIR success there for infusion. All right. So I talked about the robotic precursors, and this is amazing from phase 1 to flight in 3 years. That's a real SBIR success there. When like I said, I always say the phase 3s when a mission likes SBIR technology so much, they just come in and say, we're paying for that, we're grabbing it and running with it. And this is examples of that. Biosentinel, looking at the high radiation effects on organic material, lunar flashlight, having to, it, looking for those volatiles and everything that are on the lunar surface. Where's the best place to land? Where's the best place to drill and to mine stuff potentially, and also asteroid. This also correlates to asteroid and also to future Mars missions. NEA Scout, solar cell technology. It's also another one that's looking at a lot of times, I didn't realize this until I got part of AES, but it's really hard to look at asteroid, or I'm not even sure that they capability totally exist now, to go and to just say, hey, we know what that asteroid is made out of. I mean, you can make some guesses and stuff, but we really want to be able to know, wow, is this an asteroid? Is this a big piece of nickel out here, or and or is it something that we can go use, something we actually want to land on and can try to mine or make fuel out of, or whatever we need for deeper space missions. We got Skyfire there, low illumination mapping and determination extent matter to cold traps, where the water's at, and lunar ice. So you can see, looking out, searching for the volatile, searching for the stuff that you can use on the moon and asteroids. That's really what you want. So that brings me to the end of my talk, and I'll be glad to take your questions.
Could you talk a little bit more about the entry, descent, and landing needs?
Yes. So right off the bat, March 2020, we're reflying. The EDL from the last one. We're going to be doing more sensors on it, but people don't realize EDL is one of the biggest challenges we have for getting humans to Mars, because we haven't landed anything on Mars bigger than a Volkswagen Beetle, right? And so now we've got to figure out, well, how are we going to land these much larger systems for humans, right? And that comes down to, are you going to have to use rocket propulsion? If you do that, well, where are you going to get the fuel? Are you bringing it with you, or maybe are you going to go to Phobos first and figure out, hey, can we mine here and then produce the fuel we need to make our landing easier? And of course, at Langley we look at aerobraking and stuff like that. So yeah, it's EDL for Mars is a really massive problem, and one that's you don't hear as much about, but it's really true. You're gonna have to really land larger and larger systems as you want to put humans on the surface, and we do have to figure out how to do that.
Yeah, so as you go deeper and deeper into space, you're going to put more and more pressure on your communication system. So my question is, where within NASA are you worrying about spectral efficiency, or where would a small company interact with you on that question?
Well, that would be SCAN. That would be our space communication and navigation. And as the chart up there, the optical communication is one aspect of that, but they're also looking at the the other needs, which I definitely don't have the technical expertise to dive into, but I can definitely refer you to the scan personnel for that.
Are you looking into different architectures from the berthing docking mechanism? A bit like your water bottle there. You can only get so much in and so much out, and it's not upgradable.
I know that you're talking about the hatch designs and everything. I know that they're looking at different aspects of that. I know I was overseeing part of the expandable hatch mechanism, and so yeah, do know that that is something that we have to be looking at. Is the different ways to dock, because we also have international partners. We have to get that coordinated with them and everything. So that's going to be quite a challenge to come up with the design that makes it out to Mars for that.
Can you talk a little bit more about your interest in space manufacturing and what particular items of greatest interest to you?
Well, I think the greatest thing there is it's just looking at it as in a systems approach. What materials are you sending up? What materials are basically waste products once you get them there that they're not needed? I use packing material. Well, from a systems approach, you want to make that packing material out of something that can be melted and reused. And then you also have to think the other side of that. Well, what am I reusing it for? Is this I'm making a wrench or something? So it would have to have the material, the properties to be able to do to be melted and made into something useful. So that's a large system level approach for that.
You mentioned the SCAN program, and part of that, if I'm correct, is I think it was called Connect. I don't know if it still is, but it's a pallet on the space station that has 3 radios: General Dynamics, a Harris, and a JPL radio.
Those are software-defined radios.
Software-defined radios, yeah. Are those things or resources that might be available for a phase 2 or beyond SBIR in terms of proof of concepts if you're doing something in communications?
Well, the only way I can respond to that is we'll have to see what the solicitation for SCAN, the SCAN part of the solicitation looks like, and we're just starting that evaluation now.
So you spoke of biomaterial in-space fabrication. Could you expand on that?
I'm sorry, what was the question?
You showed you showed a picture of looked like a compressor wheel, and you mentioned that it was made out of 2 different types of materials. No?
I don't think so. I don't remember saying anything like that.
All right. So, but there is no in-space fabrication activities currently where you use 2 different types of materials. Or yes, no, you know of one?
No, I'm sorry.
So
I
made
can't
in
answer that.
space activities is only for a single type of filament.
Are you talking about the 3D manufacturing, sir?
Yeah.
I don't know that's only from one type of material.
That was my question.
Yeah, I mean, right. It's whatever material works.
I'm interested in human performance and health, and wonder what the technological needs are in order to close the gaps when it comes to monitoring psychological health.
Oh, okay. So part of HEO is the Human Research Program, and that's what they're looking at. And I can tell you, last year's solicitation, HRP is part of the HEO solicitation for SBIR, and it was almost all monitoring technologies under that. So they're looking for the monitoring technology. So what I would say is look at last year's solicitation, and we're going to be going through and choosing again. The solicitation, the subtopics change from year to year, but the last couple of years for HRP have been the monitoring technologies.
And over here, sort of adding to that question, I'm wondering if you guys have started to look into team dynamics or communications between individuals on the crew, making sure that everybody maintains.
I have no doubt they do that. That's in HRP, but I don't think that's something that would fall under the SBIR realm.
There was something along the lines in the SBIR, I think STMD, phase 1. I recall right. We may want to look into that.
Thank you.
Hello, could you please tell us more about the habitation element and the 5 contracts you mentioned and what role, if any, there is for small businesses in that area?
Okay, so with the habitation, like I said, they're looking at well, the Bigelow expandable is one. Also, you could look at potentially inflatable technologies. Also refurbishing systems that are already out there and try to fly them out further, or I know one concept out of Marshall is taking part of an upper stage from an Ares 5 rocket and making it into a HAB. Exactly, and so there's lots of different potential architectures out there to go from. There's definitely I have no doubt there's a lot of opportunity for small businesses with respect to those. I have to look at the current solicitation. It will depend on how the current solicitation goes for the habitation and which way that goes. But that doesn't mean there aren't other, small business opportunities that could connect you with those primes.
Do you think NASA will continue to participate in low Earth orbit activities after the ISS period is concluded, but you've got the Lunar Gateway, let's say? Not that there'll be a NASA vehicle, but do you think NASA will participate in, like, have a rack or two in a Bigelow vehicle or an Axiom or something like that?
I suspect there's always going to be things that we want to test in low Earth orbit and get back rather quickly and maybe look at on the ground again. So yeah, I would say that's probably going to be continuous. I couldn't see it just stopping.
What's the current plan to return both crew and cargo from the Martian surface? And is there ongoing development for single-stage orbit boosters?
So I was part of the Next Generation Launch Technology program, and I remember the single-stage to booster then. I know it was looked at quite a bit back then. I haven't heard anything about that since that time. If it's still being developed, I don't know about it. I know Glenn Research Center was kind of leading the charge on that, but since Constellation was stood up, I haven't heard anything more about that. So, and I'm sorry, the first part of your question was about returning crew. I suspect that the only cargo you want back are samples, but you definitely want the crew back.
I guess this is a bit of a generic question, not necessarily to HEOMD, but some of the HEOMD solicitations are written rather broadly. And aside from events like this one, do you have any advice on how one goes about finding a point of contact within NASA to find out what they find technologically compelling, and also what sorts of demonstrated capabilities a small business would have to bring to the table to have a good shot at getting an award?
Well, so we write the solicitations, and there's always that balance between writing it too broadly or too specific, like, oh, we just want this widget, and so it's if you looked across different solicitations, I think you'd find them for each subtopic. Some might be more broad than others, and some more closed in. So one of the best things you can do, first off, is go to NASA's small business site, register yourself as a company. The second thing is to look at the NASA SBIR website, and every NASA center has what we call a Center Technology Transfer Lead. And those are really the best first step in getting your foot into the door at NASA. You want to contact those folks at the centers that are the lead for the subtopic you're most interested in, and they're the ones you talk to. They're kind of, I'll call it the gatekeepers. They're the ones you want to talk to, and they can lead you to the technical people potentially that can help you develop your proposal. Or not develop your proposal, but guide you a bit before the solicitation blackout period.
For the Human Exploration Mission Directorate, sorry, over here.
Oh.
What are NASA's interests in surface construction or surface operations, near term and long term?
Oh, that also falls under kind of that logistics question. Are you going to bring everything with you, or do you want to get down the surface and build as much as possible? And I know there's been quite a bit of activity looking at that, say, wow, if we get to the Mars surface, first you have to study the Mars surface, you have to understand what it's composed of, and then figure out, wow, can I use that to build bricks, so I can build a habitat. It's a lot better. That falls under in situ resource utilization. That's a prime area for HEOMD, and there's a lot of study going on there, because you'd much rather use your in situ resource utilization than have to launch it, because that means mass, and that means cost, and that means you're taking less stuff that you might want to be taking, and taking construction materials and stuff.
You mentioned about the center tech transfer lead.
Yes.
And is that organization or individual different from the small business representative?
Yes, they are different. The CTTLs are specifically for SBIR.
Okay. So I'm familiar with the small business tech reps. And sorry, thank you. And you're saying that those are in the same organization as the technology transfer leads, or they are the same people?
Basically, NASA has an office of small business, and then there's SBIR, which is a congressionally mandated program. And I mean, they work together, but the CTTLs are specifically for SBIR and SBIR only. And most centers will also have a small business representative as well.
Okay.
For other opportunities that are not SBIR.
Yeah, so they also manage the center-based small business activities.
Mm-hmm. Not the CTTL. Like I said, each center will have their own small business representative as well.
Okay, thank you.
I'm being told I'm out of time. All right.
Thank you, everybody.
Thank you all.